In this lesson, we are going to learn how to find zeros by factoring and using the zero product property. So to begin, let's review the zero product property. The zero product property states that if a fully factored expression is equal to zero, then at least one of the factors is equal to zero. So, for example, we have an example here of a fully factored expression on the left and zero on the right. So what this is telling us is that either one of these factors could be equal to zero. So x could be zero or x minus 3 could be zero. One of those, at least one of those, will make the equation true. Now, since we don't know which one, we are going to assume that both will make the equation true. That allows us to solve quadratic equations using the zero product property. The biggest thing is you must have these two things here. You have to be in factored form, and the other side of the equation has to be zero in order to be able to use the zero product property. Now, I like to think of the zero product property as split and solve, and let me show you an example of what this looks like. So here are three examples, and the directions say to solve each equation. So if you look at example number 1 here, we are fully factored on the left and set equal to 0 on the right. That means that we can use the zero product property. So if we were to split this equation up, we would set each factor equal to 0. In this case, x minus 3 equals 0 and 2x plus 5 equals 0. That allows us to use our inverse operations to solve this equation using skills we already know. So on the left, the first thing we're going to do is we're going to add 3 to both sides. That tells us that x equals 3, x is by itself, so we can go ahead and box that in. We know that that's one of our answers. On the right, we have a two-step equation, so we have to undo the constant first by subtracting 5 on both sides, and then divide both sides by 2 to get x equals negative 5 over 2. As a reminder, we always want to leave our answers either as a whole number or as a simplified improper fraction. So let's try another example together. Example number 2 is already factored and it's set equal to 0, so we can go straight to the split and solve step. When we split this up, we get negative 3x plus 1 equals 0 and 10x minus 7 equals 0. Now we have two-step equations and all we need to do is solve. On the left, the first thing we're going to do is we're going to subtract 1 on both sides and then divide both sides by negative 3. Be careful here. Remember, the negative 3 is doing the dividing, so the 3 should end up in the denominator here. And remember that two negatives make a positive, so that left factor, that first factor, gives us x equals positive 1/3. On the right, we're going to add 7 to both sides and then divide both sides by 10 to get x equals 7/10. Notice, two factors, two answers. I'd say that happens about 90% of the time. The number of answers that you get should be equal to the number of x's that you have in your factored form. So now it's your turn to try. Go ahead and pause the video and try problem number 3. The first thing you want to ask yourself is, do I need to factor or is it already factored? Once you've figured that out, I'm sure you will get this problem right. So go ahead and pause the video now and see how you did. Welcome back. Hopefully you got this correct. This problem is already factored, so you can go straight to split and solve. When you split this up, you get negative 3x equals 0 and negative 4x plus 5 equals 0. Solving both of these equations, you should get x equals 0 and x equals 5/4. Please make sure that you understand the zero product property before moving on. Don't hesitate to reach out to myself or Mrs. Newman if you need help at this stage. So now it's time to put it all together. How do we use this zero product property in order to be able to solve a quadratic equation? 3 easy steps here. The first thing we're going to do is we're going to substitute 0 in for f of x. Remember, f of x and y are the same thing. Remember, what does fx say? Oftentimes the 0 is already substituted in, but this is a very important first step because if you don't have 0 in the equation, you can't actually solve it. The second step is to rewrite the other side of the equation in its fully factored form. That could take on multiple different ways or multiple different methods of factoring. The AC method, shortcut, GCF, difference of squares are all fair game here. Use those Unit 6 notes to help you figure out which method to use. But as a reminder, AC method will work about 90% of the time unless it's just a GCF problem. And then last but not least, you're going to use the zero product property to create two single variable equations and then solve to find the zeros. Remember, that's the split and solve stage. So what does this actually look like when we apply it to a problem? So let's look at this very first problem here. We're going to find the zeros of the quadratic function. That function is f of x equals x squared minus 18x plus 65. Step one is to substitute 0 in for f of x. So I was very formal here and literally just crossed out the f of x and replace it with 0. You could rewrite the problem if you wanted, but I didn't have a lot of room here. Next, I'm going to go ahead and factor this. So whether I choose to do AC method or shortcut, I need to start out by making this t-chart. Remember, here is going to be what a times c is, in this case 65, and here is going to be negative 18. So what two numbers multiply to 65 and add to negative 18? Well, those two numbers are negative 5 and negative 13. I prefer to use the shortcut whenever possible, so I'm going to go ahead and model the shortcut here, but remember you could always use the full AC method if you need to. Using the shortcut, we know that this problem factors out to be the quantity x minus 5 times the quantity x minus 13 equals 0. Don't lose that 0. Now we're on step 3, and that's the split and solve stage. So we're going to split this into two separate equations. X minus 5 equals 0 and x minus 13 equals 0. Solving them, you get x equals 5 and x equals 13. It's as simple as that. Zero product property is the new part, so hopefully we feel comfortable with that. And we just finished reviewing Unit 6, factoring, so hopefully this isn't too challenging for you. We have a few more examples to go through together as a group, but hopefully you will be on your way soon to doing these without much assistance. So let's take a look at some more examples. Two more examples here. Let's look at problem number 1 first. The first thing we need to do is we need to set this equation equal to 0. This one I did a little bit neater. Instead of crossing off the f of x, I actually set it equal to 0. I went ahead and made my t-chart. I need two numbers that multiply to negative 20 and add to negative 8. Those two numbers are negative 10 and 2. I notice that the a value is 1 here, so I'm going to go straight to the shortcut method, because again, I prefer the shortcut method. Using the shortcut method, I get x minus 10 times x plus 2 equals 0. So now that I'm factored, I can split and solve. When I split and solve, I get x minus 10 equals 0 and x plus 2 equals 0. Solving these equations, I get x equals 10 and x equals negative 2. Moving on to example 2, the first thing I notice here on example number 2 is that this particular problem is set equal to 0. We mentioned that in the original directions that oftentimes that step is done for us, and this is an example of that. So we can go straight to factoring. My t-chart here, remember a times c goes here and b goes here. So I need two numbers that multiply to 10 and add to 7. Those two numbers are 2 and 5. Now, unfortunately, I can't use the shortcut here, so I'm going to review the full AC method here in case you need that refresher. I need to split that middle term using the 2 and the 5. So when I do that, I get 2x squared plus 2x plus 5x plus 5. Next, I need to group the first two terms and the second two terms together, making sure that there's a plus sign in the middle. Now I'm going to use GCF method of factoring for each set of parentheses. The first GCF here is 2x, and when I divide out by 2x, I'm left with x plus 1. That second GCF is 5, and my leftovers are x plus 1. Notice I have that common binomial here of x plus 1, so I'm going to go ahead and divide out both sides by x plus 1. And when I do that, I get x plus 1 times the quantity 2x plus 5 equals 0. Now that I'm fully factored, I can go ahead and split and solve. I get x plus 1 equals 0 and 2x plus 5 equals 0. That's the split stage. Now I'm going to go ahead and solve. On the left, I get x equals negative 1. And on the right, I have a two-step equation. Remember, you have to undo the constant, in this case the 5, before you undo the coefficient of 2. So hopefully you got that right. Moving on, 3 more examples here. This first example is a 2-term polynomial. Oftentimes students are like, well, Brownstone, how do I actually factor this? This is just a GCF problem. The GCF in this particular example is x, so I'm going to divide out by x and get x plus 16 left over. Once I've factored, I can go ahead and split and solve. One thing I actually skipped over here is that this problem started out equal to 0, so I didn't have to worry about that step. So again, equal to 0, done. Then I'm going to divide both sides by x, that's the GCF. And then I'm ready to go ahead and split and solve. When I split and solve, I get x equals 0 on the left and x plus 16 equals 0 on the right. X plus 0 is already done, so I don't need to do any isolating. But on the right, I do need to get that x by itself. And when I do, I get x equals negative 16. Our fourth example here reminds us that we need to still start by setting the equation equal to 0. Now this particular equation also has two terms. The difference here in problem number 4 is that we have an a and a c term, whereas in problem 3 we had an a and a b term. Having a and b tells us that we need to use GCF. Having a and c here tells us that we can still use the AC method or the difference of squares shortcut. I'm going to remind you here how to do the difference of squares shortcut, but remember you could still always use the AC method. To use the difference of squares shortcut, you're going to go ahead and set up 2 parentheses. The first thing you're going to do is you're going to square root that first term, in this case x squared. The square root of x squared is x, and it goes first in both sets of parentheses. Next, you're going to square root 81, which is 9. That goes last in both sets of parentheses, and then one of those is going to be a plus, and one of those is going to be a minus. Now that we factored, we can go ahead and split and solve. To split and solve, we're going to take the x plus 9 equals 0, and x minus 9 equals 0. That's the split part. And then when we solve, the first equation gives us x equals negative 9, and the second equation gives us x equals positive 9. Now example number 5 here, a lot of times students try to multiply this out. But what actually is going on here, and it's mixed up with all these other factoring problems, is that this is already factored. Don't do more work than you have to. Go straight to the split and solve stage. Splitting it up, the problem looks like this, and then solving, we get x equals negative 2/3 and x equals 5/2. Again, if you are factored on one side and equal to 0 on the other, don't do more work than you have to. Go straight to the split and solve stage. Okay, now our last 2 problems here. These problems look a lot different than the others. Hopefully you're realizing that we have terms on both sides of the equal sign. We have 1 term on the left and 2 terms on the right for number 6. And we have 2 terms on the left and 1 term on the right for number 7. In order to be able to solve this, we need to get all the terms onto the same side of the equal sign. Now, while there's multiple ways to do this, I always recommend moving towards the x squared. It is much easier to solve an equation when the x squared is positive rather than when the x squared is negative. So looking at question number 6, the first thing I notice is that I want to add 12x to both sides. When I do that, it's going to cancel on the left. On the right, the 12x will cancel right here on the right side. And then you'll end up with an equation like this. X squared plus 12x equals negative 36. Notice I'm arranging my terms so that they are in descending order. In order to be able to factor, we need to be in descending order, where we start with the biggest degree and work our way down. One more term to move over, and that's this negative 36. In order to move over the negative 36, we need to add 36 to both sides. When we do that, we get x squared plus 12x plus 36 equals 0. Now we have 0 on one side, so that's our first step to factor. Then we need to go ahead and, solve here, set equal to 0. Next, then we need to factor the left-hand side. So when we do that, we get a t-chart of 36 and 12. What 2 numbers multiply to 36 and add to 12? That's 6 and 6. When we factor that, we get the quantity x plus 6 and x plus 6 equal to 0. Splitting that up into 2 equations, we get x plus 6 equals 0 and x plus 6 equals 0. Both of those equations solve to be x equals negative 6. So you're welcome to write that out twice, or you can just say x equals negative 6. Let's fix that here. X equals negative 6. Either way, you can write it twice or you can write it once. Most students choose to write it twice because they know that they've covered all their bases. So one more problem here to do in this lesson. Only 1 term to move this time, and it's that minus 12x. In order to move minus 12x to the other side, you're going to need to add 12x. When we do that, we get x squared plus 12x minus 45 equals 0. Now I want you to pause the video and see if you can finish solving this problem on your own. We're already set equal to 0, so what we need to do is we still need to factor, split, and solve. So what factoring method is this? I would start with that. Once you figured out the factoring method, go ahead and factor, split it up into 2 equations, and solve it. So go ahead and pause the video now. Okay, let's see how you did. Here is the fully worked out problem. Hopefully you got x equals positive 3 and negative 15. Your t-chart here, it's really important that you watch your signs here. To have a negative product and a positive sum, you need one positive and one negative, and that can sometimes throw people. If you're having trouble with any of this, whether it's zero product property or these more challenging problems or anything in between, please reach out to Mrs. Newman or I to get some extra help. You are now ready for your homework, and I hope you enjoyed this lesson.